So again, the essential question, how can we view functions? Topic has 3 views of a function. Today's 9-4. We're going to make sure all of those are in our guided notes. Let's start. All right, you've got this example 1 already written down. Suppose a car gets 30 miles per gallon. Then the distance, which is going to be represented as d of g, that the car travels is a function of the number of gallons. One of the ways we can view all this is by setting up a rule. A function rule, you might hear it as a function, you might hear it as a rule. Typically, we like to say y equals mx plus b, but we don't really make sense of it. It's a rule. A function rule shows how the variables are related. And in this case, the distance that a car travels is, well, 30 miles per gallon times the gallon. So let's talk about the table of values in reference to this function. The table identifies specific values that satisfy the function. Go ahead and get these down. If you have no gallons, well, then you can't go anywhere. So if you have no gallons of gas, can't go anywhere. If you have 1 gallon of gas, you can go 30 miles. 2 gallons of gas, you can go 60 miles, and so on. So now looking at the graph, you have this graph, and I want us to circle some things in the graph. First off, the graph is a visual picture of the function that we're talking about. Notice how the y-axis is labeled d of g. Please circle that. Circle that on your piece of paper. D of g is our y-axis. That's the distance. So let's put by it that it's the distance. And then we've got the x-axis is all about the gallons. How many gallons of gas? When we do these word problems today, we're going to make sure we have labels for our axes. And typically for our word problems, we'll just be dealing with the first quadrant. Using the previous info on your notes, what if we used 14 gallons of gas? How far can the car travel now? Several ways we can do this. Probably the easiest is maybe using the function. We're not really used to this function notation, but the distance is going to be equal to whatever 30 times 14 is. So what is the distance? When we plug in 14, what's the outcome? When I plug in 14, I need to just realize that, okay, the distance when 14 gallons are plugged in, that's where I'm taking 30 times 14, I hear 420. So really, what is my answer? How far did the car travel? 420 miles. Let's always end with a unit. If we start with some sort of word problem, we've got to make sense of the problem. 420 miles. So for everybody at home, take a moment, press pause, and read the problem. We're looking at this table. We're going to fill it in. You give me some inputs. So we're going to just pick some number of hours, and then we're going to plug it into the cost function. So I'm going to take, all right, and multiplying 40 times 0 is a 0, so 68 plus 0. Looking at a 68, and let's pair it up. So if I needed to graph it, which I'm going to have to do later, number of hours is 0, and then the cost is $68. Within this graph, we need something for the x-axis. So for the x-axis, we're going to label it h. This is the number of hours. So number of hours. And then for the y-axis is going to be our cost. Notice how I'm labeling it. Once we set up the graph, now we're ready to plot. After we plot, let's make sure we put in an arrow. You're going to be moving on to geometry after algebra. And the thing about this is we're going to call this array. it's a ray, because technically we can't go on the negative side when we're dealing with an electrician and cost. So because we can't go the other way, it's just going to only have one arrow. It can keep on going depending on how long he's at our house. So we're about to practice in class. It's page 17R. We're going to practice problems. We're going to do problems 12 and 13 together to just get an idea. And then however long the time persists, we may be able to do the rest of these. I'm going to give you graphs to stick into your notes. But I want us to drill this in our heads. So the rest of the time we're going to practice together.